Hello guys, welcome back to my YouTube channel. Today we are going to create a drawbridge. Basically this is the improvement of my old video in which you had said that there is no audio of the video. Mm, There was a problem in the audio because I did not have mic at that moment. So let's get started. First of all, we will create a blueprints folder. Basically you can create the blueprints anywhere. I don't restrict it, but I just want to keep the things organized. So under this folder, we create a blueprint class and then an actor, and I would name it drawbridge BP. BP means blueprint, and we will open this blueprint. And now you know that if we search on the Google a drawbridge, we need to create this kind of bridge. There is actually a lot of drawbridges. This is the modern, and this was the old drawbridge which was used to protect the entrance of the castle. So we will be using this kind of drawbridge. So let's get started. First of all, we have to add a cube here, and we need to modify the dimensions. This would be about half, and the z-axis need to be actually higher, about 3. And location, we need to change the location as well, like this. To keep the sense of scale, we need to bring some kind of reference, which is nice. I think the third person character, which is by default given. So we will just drag this third person character here and check where are we actually standing. We need to bring it back to this main. So we will just bring it somewhere. Okay, so we need to make it like this. Yep, that's nice. I think it's good. Otherwise we can also increase it to 3.5, which is basically something like castle. It's up to you, whatever the height you want to keep. I'm just demonstrating the functionality and the way to do it. All right, we need to duplicate this, but before the duplication we will apply some material to this to make it look more nice and realistic. Not actually too much realistic. So under the content directory we will go to starter content, and here you can see materials. From here you can choose any kind of material. It's up to you. I would choose this brick or rock or whatever. You can actually also do drag and drop here. It's up to you, whatever you think would be good. Stone, I think stone is more suitable. Does it? No, it makes it look rough. Well, that's nice. Yeah, that's kind of nice. Okay, now we need to duplicate this. Control D and bring it somewhere here, and bring it somewhere here, because we want to keep the things in the center. So we would do it like this. It's totally how much the gate you want to keep. I'm creating the small one. Okay, we will again just duplicate it and bring it into the center, and increase the width, which is at the moment 0.5, and we will increase it to about 2. Yeah, it filled up the gap. And now we need to modify its material. We will again open the materials tab, and I think the gate should be made up of metal, so we will look for metal. Yeah, here it is. metal burnished steel. We'll drag and drop these to metal. Yeah, nice. Okay, that's cool. Why not to fill up some gap? Yep. Okay, as you know, the gate should not be this much wide. So instead of 1 to y-axis, we would do it 0.2. Yeah, that's cool. And there should be also a base. For the base, we will duplicate this, Control D, bring it to the center, and reduce its z axis, and we will just do it to 0.5 and bring it down and increase the size, which is actually it's 2 and 2 and 5. So 0.5 both sides plus the middle one, whole of this would be 3. So we will change its width to 3, and it now covers the base. We need to make sure that things look nice, because nice people make things nice. I don't know, I cannot make it fit, I think, because yeah, almost there. I'm not going to waste the time on designing this thing. Let's move to functionality. So we need to remove this dude here. Okay, first part of our drawbridge is almost ready, and the next one is to make it open and close. And for opening and close, the logic is very simple. The logic is to rotate this gate, and if we just rotate it about x-axis, if we rotate it about x-axis, you can see that it is rotating in the middle of the cube. So we need to change its pivot point, but there is no standard way of changing the pivot point. First of all, let's rename so we don't forget what is the metal door. And if you want to rename these, you can also do, but this is the important part, so I'm going to make it renamed. And from here we need to add a new thing, which would be actually arrow or whatever, but I am going to add a scene here. This is called the scene, not scene capture or these things, just a scene under the utility tab. We'll add this scene, or let's rename it and call it specific pivot point, and drag this metal door in the scene. And now you can see that scene actually starts from here. Scene actually starts from here. If I bring it down and rotate, the gate will also actually come along with this scene and also rotate with the scene. So as you can see, the pivot point is changed because it is now the child of the pivot, this pivot point basically scene. So what we will be doing, we will be changing the location of the metal door and bring it upward. And here you can see the difference. If we click on the pivot point is low, and the center of metal door is high. So basically we need to adjust where we want to rotate our door. Actually, I will keep it touched to this base. Again, we will grab this door and make it fit to the window. Okay, now if we just rotate this pivot point, the door is actually closing and opening at the right direction. Now we have to do it programmatically. We need to do it from blueprint. Basically, we need to enable the interaction of the player with this gate. You can use it in the movies and cartoons and wherever you want to use it. First of all, we need to go to event graph, and you know that for the interaction with the player we need to add some kind of uh, collision box. But before that we need to know which one is the positive side and which one is the negative side of the rotation. So if I just go there, sorry, not this one, we will be checking the pivot point. Yeah, yeah. So what we have to do, we will just put the interaction box here. If the player comes at the gate will open. When player leaves it, it will automatically close. So from here we need to click on the default scene route and click add and type box collision, and it's here, box collision. Click on this box collision and bring it outward where you want to keep it, where you want to start the interaction with the user, with the player actually. Now let's resize it to make sure that the user actually catches up the interaction. Something like this. You can make it fit to your requirements. Actually, it is enough something. Yeah, that's cool. Now, when selecting this box, scroll down under the details tab and click on this on component begin overlap. This will automatically bring you here in the event graph. Here we need to close and open. Basically, when the component begins overlap, it will close and open. But before utilizing this, I am going to show you a simple thing, like how this closing and opening will work. We need to add a variable. We will add a variable closing. First of all, let's do with opening. This will indicate whether the door is opening or not. Let's make it blueprint editable, instance editable, sorry. We will click on the instance editable. Now we need to make a function which will handle the opening and closing of this. We will add a function here and call it open gate. Now what this open gate will do, it will just rotate the scene so the door will be open. Drag this pivot point here, point this check, drag this check here and get the opening. Now drag from here and type if. It basically says if opening. Then what we need to do, we will basically get the rotation from here, get relative rotation and split the struct pin. As you know, rotation can be in 3D, in x-axis, in y-axis and in z-axis, and we need to rotate it to rotate this to only x-axis. As you can see from here, if we just do this, we need to rotate it to x-axis to make it work. So we will be rotating along x-axis. So if we go to open here and here again drag this and click set relative rotation, click on this transformation tab. Here is the symbol of our logic. We do not need to touch the y-axis and z-axis rotation. So we will just simply drag this to Z axis and drag Y to Y axis. We need to modify the rotation of along X axis. What we will be doing, we will be adding up with the current rotation just 1 degrees. We will add 1 degrees to the current rotation. Now let me show you the demonstration, like what it does actually. If we drag this gate here, it's and under the opening tab I will just keep it opened, and from here in the event graph on the event tick we will I will be just doing just drag this function open gate and drop here and just connect it on the tick event with this. What it will do, it will call each frame on the each frame or each cycle of the game. It will call this function, but we need to call it only when it is opening. So if we will just type it if and connect this, and when it is opening then we will be doing this. So let's test. You can see it's opening here and it will just keep going, and again it will come again here from the other side like this. It will just keep going on because we have not restricted it to only 90 degrees, because this should be the 90 degrees and it should not go further than 90 degrees. So here in the open gate function we have to add a check here. If this x-axis rotation is greater than 90, then we will just stop it here. So let's do it. Drag a pin and type if it is less than 90. So if it is less than 90, then just drag it here and type if. Drag from here and type if. Connect this true pin to this pin and connect to this pin. So now what it actually does, it just checks if the current rotation is less than 90 degrees, then it will set the new rotation by adding 1 degrees. Otherwise it will simply ignore, it will just not do anything. So it means that we are not closing it anymore, has actually reached the 90 degrees. So what we were doing, we set this to false. If it is not less than 90, which means that it is greater than 90 or equal to 90, we will just set this to false. Unchecked means false. So let's test now. It should stop at the 90 degrees basically when the gate is fully opened. Yeah, it stopped. No, this is just automatic and it requires no user interaction. So let's make it user interactable by going to event graph here, and by default disable this opening in the instance. I will just disable there. On component begins overlap, and we will just set this opening to true. Now what it will do, it will basically whenever character comes up with that box, then it will just start opening. Now let's go to our level and uncheck this opening, because we are not doing it automatically. Now you can see it is not opening automatically, but when the user comes there, it will start opening. Yeah, but there is another issue. If we just do it again, oh yeah, it will not do it. So next we have to do, if the user leaves it, then we have to close it as well. So let's make it in the opening. We also have to add closing. Okay, so as it's basically with this component, if you know that if it is opening, and if it is not opening, then of course it would be opening, and if it is already opening, it's something like this. So if it is opening, then no, this is another issue. We also have to keep the track whether the gate is opened or not. So we will just add a new variable and call it opened, and other a new variable and call it closed. Okay, so here we have to check if it is opened. If the gate is opened, if the gate is opened or it is opening closing, then it will start again doing it. If the gate is opened, then we will just set closing to true, so it will start closing. So what it does when the component begins, when the user interacts with it, it will check if the gate is opened, then it will start it closing. But you know that we need to change the value of opened here, and in the open gate function which you have made here, open gate, in the open gate function, when the 90-degree reach, we will stop opening and mark this as opened. Mark this as opened. Now it will see that, yeah, it is opened gate. If it is not opened and it is closed, which would be by default closed, of course, we will get here, and of course under the condition false. If it is closed, then we will start opening and just drag here, and yeah, we will start opening. And now you can see the logic here. This is the core logic of this automation. When component hits and it is opened, then it will start closing. Otherwise, if it is not opened and it is closed, then we will um, start opening it. But there is no function to deal the opening function. For example, here we have this opening, but we have not made any closing function here, so we need to add a new function, call it close gate. And in the close gate we will be doing the same thing which we have done here. So instead of writing everything again, we will just copy these things from here. Come on. Okay, somehow I did not copy it. It's not. Why? What's wrong? Come on, dude. Control C, Control V. Wow, that's nice. Even things don't work as per expectation. We need to save it. Okay. So this is the entry point, and this is the first check, and this is for closing the gate, and we will be doing only when it is closing. So drag this condition here. So if it is closing, we also have to change this thing. If it is closing and the x-axis rotation is greater than 0 degrees, then we will keep doing that. And we have to actually, to close the gate, we have to reduce, like we have to subtract the x-axis rotation. So we will subtract the rotation. From here we will mark closing to false, and then mark it as closed. Yes. Now go again in the event graph, and we have to use this close gate function. Here we will check if it is opening, then open the gate, and if it is set to closing, if it is set to closing, sorry, my bad, and if it is set to closing, dude, come on, we have to actually gets its value basically. And if else if it is set to closing, then we will just close the gate. So bring it here and drag on this true socket. Now let's test this behavior, and there can be a logical flaw in the blueprint, so we have to test if the logic is correct. Actually it is not setting anything. That's strange. If it is opened and then it is closed, yeah, we have not set the default value of the closed, so we have to check it default. As you know, default value is closed. So now let's check. It actually not triggering the leaving it or the double trigger. Something is wrong with this. If it is opening, then opening, otherwise closing. It's not doing closing basically, which means that opened is not marked correctly. So in the opened is true. Yes. For the debugging purpose, you can always print variables. So we will just set it closing now. And we can also print it here to check if there is another thing to do with this. We can have another option which is pretty cool, which actually allows us to handle all of these interactions. If we click on this box and go, we need to increase its size little, like this. Okay, in the interaction we can own component and overlap, and here in the component and overlap we can call the function to close it, because when the user exits, it is ending the overlap. So here we need to just call it if, and if the gate is opened, then we will set it to closing. And that's simple logic. Now check our tick. Here I think here should be there is resolution. If it is opening, then true, otherwise if it is closing, then close the gate, and that's correct logic. Let's see. Now gate is opened. Actually, it is not triggering the exit. Let's print some log. So here we exited, closing now, and here we need to print opening, and let's test. Most of the time gets wasted in the testing. As you can see, it is opening written on the left side. It's the exit, and in the exit it is not triggered closing. Here in the exit, closing, and here we need to put not opened. So let's see what's wrong with this, why it is not closing the opening the gate and closing the gate back. It is closing, actually it is setting up, it is setting the variable closing to true. It means that there is some kind of error here in this, and we can actually call these two simultaneously instead of just doing these if conditions here, because we have already put the if conditions in these both of these actually. So we can also delete these conditions and type it sequence. In the sequence it just calls one and then calls the other one, two functions basically. First of all it calls the one function and then calls the other one, because the speed is too quick and it does not let us realize that it is called one by one. No, let's see. Yeah, no, these are called both of these at the same time. There is some kind of logical error in the closing gate function. Okay, let's debug this closing gate function. Here we have told it if it is closing, then we have to check if x rotation is greater than 0. We can just type -1. Then we have to subtract. Oh yeah, that was the error actually. We were subtracting 0 because 0 does not make sense. Okay, that was the error. Let's now test it again. Now let's come back. Let's go again. Open SimSim. It's not opening, and that's another error. Basically all of these are logical errors. Okay, so there could be any error. For example, it could be this value or could be these values. Closing is set to false and gate is marked as closed, and marked as closed, and of course, yeah. Now let's say what is wrong with opening gate. If gate is opening, then opened is marked and opening is set to false, and in the event graph this has to be triggered at this on actor begins overlap. So there should be at least opening and closing print. Now there should be another print when we enter it. It is again saying closing now. So it means that there is error with this. So if it is opened, then it will closed. Well, that's an error. So what we have actually we have to do, when the gate is opened, we need to mark closing and closed both false, and when the gate is closed, we will mark uh, opening and opened to false. Let's do it. When this is done, we will mark all of these to false because it is not opening anymore and it is not closing as well. So gate is closed, we will mark this. Sorry, gate is not closed. Set gate to not closed and not closing. Both of these false because it is neither closing and not closed. And here we have to do with the same opening and opened. So we will set this opening to false because when the gate is closed, it is not opening anymore, and gate is, of course, it is not opened as well, so we will mark it here false. Let's test it again. That's cool. And you know that this is the strange thing. So when even if even if the process is not complete, when we exit, there should be the reverse of the thing. So we have to say if it is either it is closing or it is closed. In the both state, the operation should be reversed. So in this condition, if it is closing, we will just do it, or type or here or, and there will be or boolean. We will put two pins in this and drag this pin to here. So if it is closing or it is or if it was basically closed. But let's keep it simple here. We need to handle this on the outer side of our functions. We will handle it in the event graph in this logic. So here we can see we just need to keep this as for now. Here we need to think about this, like if the user leaves, basically if the user leaves this and the gate is opened or it is opening, then it will start closing. So we need to modify or here, and it is pretty simple logic. So if gate is opened or gate is opening, in both cases when the user leaves the gate, it should start closing. Now this can be another mess. no, it just stopped some because both of the variables are set to true, and it just adds and then subtracts, adds and then subtracts, adds and subtracts. So that's what is going on. It just stopped there. It just adds 1 degrees and then stops 1 degrees. So we need to soon after this condition becomes true, we will set the opened to false and opening to false both. So here we need to set these to false. It is not opening anymore, and also it is not opened anymore. Actually, it is opened. But it is not opening. It closed. Let's go do again. Come back. Go again. It closed in the half. Let's come back. Go again. And that's the exactly expected behavior. That's it. And no, you can place it wherever you want to place it. It's your level, it's your game, it's your thing, and you can do it whatever you want to do with this. But always remember that to keep the sense of scale, when you are scaling it to size, just always lock this mm, scale parameters. So when you scale it to x-axis or y-axis or wherever, this will basically scale to all of the same time, keeping the dimension and the scale ratio. And where did I had actually used it in the previous video? Somewhere here. To go from one place to other, basically I don't have a castle here, so let's place it here. Let's go to this door. Oh, the mighty door. Yep, that's nice. And hope you have liked it, and now the audio is clear. And if did not or have any confusion, you can tell me in the comment. I will try my best to explain that part. And take much care of yourself. Bye bye.